Hi, welcome back, everyone. Kind of anticipated we would have a small class today since most people want to just stay home with this weather. So I appreciate you making the trek out in this weather to be here. First thing I'd like to do is answer any questions, entertain any of the problems from homework that you might have had trouble with. Fractions, okay. Any particular problem that you'd like for me to look at? 41 through 45? Well, can't do all of them, so we'll pick some. Let me start. I'll try and go in order. Let me start with 45 because we did not do one like 45 in class. So I think it's worth us taking a look at. Number 45. We have x minus 3 over 3 plus x plus 2 over 4 equals 11/6. All right, here we go. So the first thing hopefully you notice on this is that it is a linear equation, all right? So we have our equal sign, we have our x's, they're raised to the first power. But this is the first problem that you've seen where you have two terms over one denominator. The other fraction, two terms, the x and the 2, added together over the denominator. Everything up to this point has been a single term over a number. If we had a fraction, it was just single thing over a number, single thing over a number. So we need to first interpret what that is and understand what that means. So let me help you here. If I rewrite this as x over 3 plus negative 3 over 3, is that the same as the green there? Yes, because how do we add fractions together? You have to have the same denominator, right? If you have the same denominator, then you can add up the numerators. So check this out right here. Since they have the same denominators, I can put them together by combining the numerators. So if I combine those numerators together, x plus a negative 3 is the same as x minus 3. So on the top I would have x minus 3, and on the bottom I would have the common denominator 3. So usually what we do is we add fractions together. In this problem, it might be wise for us to take that expression there in the green and take it and break it apart into two fractions. If we do that, then it'll look more like what we've done before. Okay, so that's what I'm going to do. I'm going to break those two apart into two fractions, and I'll do the same thing on the blue here. So I'll do everything down here in red. This was just to show you what was happening. The first one here becomes, we just said x minus 3 plus negative 3 over 3. Then I have the plus sign in the middle. Now what does the blue turn into? X over 4, right? X over the denominator, then split it plus the 2 over the 4 equals 11/6. All right. Now there's some other stuff I can do here. Any questions though? There's some other things I can do here. Notice that negative 3 over 3 is just negative 1, right? It's a whole number. It's negative 1. And also the 2 over 4 is a fraction that can reduce to become 1 over 2. So I'm going to choose to simplify that out a little bit first. I have my x over 3. Nothing changes there. This is going to turn to a minus 1 because I'm adding a negative 1, same as subtraction, plus x over 4 plus 1 over 2 equals 11/6. Okay, that's the way I've chosen to do this problem, by splitting each of those fractions up into two fractions each, and then now cleaning it up. Now let's start our steps. First step is to remove grouping symbols, right? We don't have grouping symbols. The next step is to clear fractions or decimals. We do have fractions, right? So what we'll do to clear fractions, I'm going to put my steps. Step 1 is good. Step 2, clear fractions. That's what I'm doing right now. I'll share a little story with you real quick. In one of my other classes, it wasn't this one, we were going over this same thing, solving linear equations, and I had a couple of students that came to my office for some help, and what I noticed, the things that they were struggling with, were following the steps. They were trying to do everything, I guess, the way they had learned it, which is fine if you do it right, but the problem was they weren't doing it right. So if the way you're doing it, you're getting mixed up and you're confusing things, you need to really get used to a systematic approach, step by step by step, showing as much work as possible. So as much as I was sitting right next to them telling them, look, here's the step, what's that step? They still, even in front of me, did not want to follow the steps. So I encourage you to, try and take my advice and follow the steps if you're having trouble with these. Yes? Sure.
From the top, the way the column is already,
yes.
Can you do the LCD that way?
Yes, you can. Yep. You could have done it up here.
I think it's different than that. The LCD.
Sure.
From there, I just broke it down.
Okay. And I don't mind going through that after I do this. I don't mind showing you that way also. What I really wanted to stress by doing it this way is to help you understand that what's in the green and the blue there actually can break into two fractions. Because a lot of times we lose sight of what that is. So you can do it, yes. Okay, so I need to clear the fractions. So to clear the fractions, we have to find an LCD. And to find an LCD, we look at all the denominators. So I'm going to look at, I've got a 3, I've got a 4, I've got a 2, I've got a 6. So 12. Now, how do we get that? I think last class I showed you we make a list, right? We write down all the numbers that we have down there. We have, I'll put them in order. We have a 2, we have a 3, we have a 4, and we have a 6. And what we do is we list out, for the LCD, we list out all the multiples of those numbers. So I'll start with 2. What are the multiples of 2? 4, 6, 8, 10, 12. I could keep going, right? For 3, all the multiples of 3 are 6, 9, 12, 15, 18. I could keep going. 4, 8, 12, 16, 20. Keep going. 6, 12, 18. And what are we looking for? Which is the smallest number that appears in all of the lists, right? The smallest one that appears in all lists. So the smallest number that appears in all the lists is 12. So that's our LCD. Now, what do we do with our LCD once we've found it? So once we find the LCD, which is 12, we multiply, right, both sides by the LCD. So here's the way I'll write it. I'll do my 12 in red. My 12 is going to multiply times the left side, and my 12 is going to multiply times the right side. I just kind of set it up already. I'll fill in the blanks. 12 on both sides. I use the parentheses to help us remember that we're going to distribute. So 12 times my left side was, what, x over 3 minus 1 plus x over 4 plus 1/2, right? That was my left side. My right side was what? 11 over 6. And now I distribute. So I'm going to pass the 12 through 4 multiplications there. So we remember that 12 is 12 over 1, right? So when we do this first multiplication, 12 over 1 times x over 3, I'm going to show a little more work because when I sat down with a couple of students giving help to them, I found that writing that step helped out a little bit. That's my first multiplication. My second multiplication will be 12 times negative 1. My third one will be 12 over 1 times x over 4. And my last one will be 12 over 1 times 1 over 2. That make sense? And now, on the other side of the equation, I have 12 over 1 times 11 over 6. So if you want to look at it this way, we have that multiplication, that one, that one. So 4 of them on the left and 1 on the right. So what happens here? The first multiplication here. 12 and 3 becomes 12 over 3 becomes a 4. So we have 4x. What's 12 times negative 1? Negative 12. And then on the third multiplication there, 12 divided by 4 is 3. So we get plus 3x. And on the last one on the left side becomes a what? Plus 6. Equals. Now on the right side, I can do 6 goes into 12 twice. And then we still have an 11 there. So this will be, the 12 over 6 will turn into a 2, right? And then times 11 will be 22. All right, now what we have now is an equation, a linear equation with no fractions, which is what we wanted. And if you do your LCD right, you should never have a fraction after this step. You should be ready to go. So what's the next thing that we do? Like terms? Like terms. Okay, we have on the left side 4x plus 3x. We can put those together. That'll be 7x. We could also put the negative 12 and the positive 6 together. That gives us negative 6. The other side of the equation is still 22. Okay, so we've moved on. This was step 3, right? It was collecting like terms. Step 4 is to do what? Isolate the variable. So we need to get the variable term. So we need to get the 7x by itself. So we need to remove a minus 6 on the left side. So how do we do that? Add 6. So we add 6, add 6. On the left, they go away. So we have 7x. On the right, we have 28. Fifth step is to get the x by itself. So remove whatever is in front of it, doing whatever you need to do. So like multiply or divide. In this case, we'll divide by 7, right? Divide by 7. Divide by 7 because we want the 7 in front of the x to cancel. Or actually, it's called reducing, but we'll say cancel. It reduces to a 1. But a lot of times we say it cancels, like it goes away. So we have what on the left side? Left side is x, right? And then on the right side, 28 divided by 7 is 4. Okay. Now we're supposed to check the work. We won't do that because this was a homework problem. So I hope that helps with that one. Okay? Yes? Oh, no, you can. I'm just not going to do it here. Yeah. I mean, you should check for your own, benefit, getting that practice. Because, maybe on the homework you'll feel good about your answer. You can check your answer in the back of the book so you'll know if it's right. But on a test, if you don't know what the right answer is, you might want to get used to checking it so that on the test you know, okay, yeah, that works. That worked out. Mm-hmm. Let's just say yes. I'll ask you to check it. The only drawback to checking is the time. That's all. If I ask you to check every problem, then that's going to take away a good, 10, 15 minutes of possible time in class. I mean, that you have for the test. Yes? I am done. 51. Okay. So 51. Ooh. 14m minus 2 plus 5m. Good. Wait, that in front of that 2 is a brace. Did you look in the back of the book for the answer? All the answers are, all the odd ones are back there. Just the answer. It's not worked out, but that way you can see. Okay, did I do it? You didn't want you didn't want to have to work it all out if it was wrong. Okay, so on this problem, same thing. Going to look. It's a linear equation, one variable. Oh, sorry, we didn't talk about that last time. Linear equation. We have our variables m. It's raised to the first power. We're happy. Okay, so first step is to remove grouping symbols. I have braces and then brackets and then parentheses. So I'm going to look at the parentheses first and try and remove those parentheses. The only way I can remove those parentheses is to do what? Distribute what? A -1, right? That 6 is not going to be distributed. The 6 is out front. So we look at that negative in front of that parentheses, like that red 1 I just put there. That -1 goes through. So now again, I'm going to rewrite everything. Waste paper. I have a theory on recycling, which I'll share with you. Yes. So first of all, when I distribute that -1 through, right, -1 times m gives me -m. -1 times -2 gives me +2. And when I went around the other day and was looking at everyone's work, those were the types of little things that people would make mistakes on. They distribute through and they would put -2 instead of +2. And of course, once that's wrong, everything else is going to be wrong. So you want to be real meticulous about checking. Don't get all the way through before you go back and check. Do the work, then just maybe go back through visually with your pencil. Make sure everything looks good. Equals -10. Okay, so I have removed the parentheses. Now, I would normally, okay, I would put the 6 and the 2 together right now to become an 8. But when I walked around, I saw a lot of people didn't do that. It's not wrong, but I saw a lot of people just went to the next distribution. So let's just take a quick vote. What's that? I said if I were doing this problem, I would put the 6 and the 2 inside the bracket together. But when I walked around, a lot of people didn't do that. So let's just see. How many of you would put the 6 and 2 together? Okay. I guess everyone else is gone today. So all the other people that would do it the other way. Okay, it's not wrong to do it the other way. It's just, as long as you follow the rules, everything should be okay. So I'll go ahead and put the 6 and the 2 together. That'll become an 8. And here goes more trees. I can hear the saws and the echo of the saws in the forest, Poor trees. Anybody here ever listen to a comedian? He's not around anymore. George Carlin? Yeah? He's got some pretty good views on nature. In particular, he likes the human race to like a bad case of fleas on a dog. It's kind of like, at some point the earth will just kind of shrug us all off and we'll all get recycled. Okay, so I've done the parentheses and I've wasted another line, but now I need to get rid of the brackets, so I want to distribute the -1 through, right? Here and here. So what I'm going to have is a 14m. I have -2, my brace, 3 plus 5m. Now here we go. What do we get? -8 plus m. No more bracket, right? Just the brace equals -10. I think y'all are ready for a test. Not yet? Okay. So now again, I would go through, I would combine like terms within those braces. So I can put together a few things. I can put the 3 and the -8. Now, I've been asked about calculators. I don't mind you using calculators. Here's my fear. Here's the thing I don't want you to get used to with a calculator. I don't want to have a problem like this, 3 minus 8, and you're looking for your calculator. All right? That's the type of thing you should be able to do mentally. You don't want to become so dependent. I mean, I've seen it many times, where it's even something like, 4 plus 13, and it's before the person even thinks about it, it's straight to the calculator. And I don't want you to become that type of student, because if you just stop for a second, you can probably do that, right? Just give it, give it a moment. Give your brain a moment to catch up. Okay, so what is 3 minus 8? -5, right? -5. And then what's the 5m plus the m? 6m. And close the brace equals -10. Okay. So 14m. Now what I'm going to do is I'm going to distribute the -2 through the brace to get my braces out of there. So I have 14m, then what? Plus 10 minus 12m, and then I have the other side of the equal, so equal -10. Whew. Okay. Any questions? We've removed all the grouping symbols, so step 1 is done. Step 2 is clear fractions or decimals. Do we have fractions or decimals? No. So step 2 is done. Step 3 is to combine like terms. We do have some like terms. We've got a 14m, we've got a -12m. That's going to be 2m. And the 10 by itself there can't be grouped with anything, so I'll just bring it along for the ride. So step 3 is done. Step 4 is to get my variable term isolated. So I'm going to go ahead and do what? To get that 2m by itself, subtract 10, both sides. When I do that, cancel out, I get 2m on the left. On the right, if you take 10 away from -10, you get -20. All right, last step, step 5, is to get the m with basically a 1 in front of it. So what can I do to get rid of that 2? Divide by 2. So I divide 2 here, divide 2 here, and that gives me my final result. M is equal to -10, because negative divided by positive is negative. We're done. Yes? 33? You want to know the answer for it? Yeah, okay, 33. This will be the last one I do, just because we do need to move on. And remember, I don't mind going through homework, but I do prefer that you would come to me for help, because in like a college algebra class, or even an 0303 class, which would be the one after this, what we do is we spend less time doing this sort of thing, where we go through and we talk about the homework. And what it is really the subject material is presented. You go home, do the homework. If you can't figure it out, you go get help. And then when the next class starts, you just start new material. And so there's not a whole lot of that time to sit back and reflect on things. So I want you to get that kind of mentality of, before you come in here, you've resolved those issues. You've talked with me, or you've gone to the lab. So I'm not denying you. I'm just saying let's just keep that in mind. Okay, so here we go. This is a linear equation. Now, you see decimals and you see grouping symbols, right? Which one do we do first? According to our steps, what is it? Grouping symbols. And my advice to you is to follow those steps, because if you try and remove the decimals right now, it gets a little bit dangerous. The danger is the fact that you have a decimal here, but within the parentheses, you also have a decimal. And if you don't distribute properly, like remember, we're going to multiply, we're going to move all the decimals over. If you don't do that properly, you can mess it up. If the grouping symbols are gone, you don't have to worry about that. So that's why I advise you to follow the steps. Remove grouping symbols first. So how can I remove the grouping symbols here? I need to get rid of the parentheses, right? So I need to multiply or distribute a 0.8 through this parentheses. And yes, you might need your calculator here. What is 0.8 times 2? 1.6. X though, right? Because we had that x. So I'm going to have plus 1.6x. Now the next multiplication, I need to do 0.8 times -0.1. So you go on your calculator, 0.8 times times 0.1. It's going to be 0.08. It's the decimal, then a 0, then the 8. So it kind of added a 0 in there when you did that. Yes? You don't have to write that 0 in front. This one right here, what that does is that sometimes it helps students, they'll forget or they won't see the decimal point. So that 0 in front kind of helps you see it. In all my life as a student, I never wrote that 0 in front. But now, now that I'm teaching it, I try and follow what the book does, and the book puts the 0 out there. Okay, equals. Now, the other side, I haven't done anything to, right? But I have removed all grouping symbols. So step 1 is done. Now I go to step 2. And I say, I'd like to get rid of any fractions or decimals. I actually have decimals here. So what I need to do is figure out how many decimal points I need to move over so that I don't have any more decimals, right? The first one, 6, is already a nice number. I don't care about that, right? Okay, 1.6, I would have to move one place over to make it a 16, wouldn't I? But on this one, I actually have to move the 0.0 at 2 places to make it an 8. And then on the last one, I need to move it 2 places to make it a, what, 15,193. So I'm going to, since I'm going to need to move 2 on those last 2, that's what I'm going to have to do to all of them. I'm going to have to move all of them 2 decimal places. Everything, not just the ones I want. All of them have to do the same thing. So I'm going to take my 6 out front here. My 6, I imagine my 6 is a 6.0, right? I'm looking at that one up front, and I move the decimal 2 places to the right, which becomes a what? And there is a 0 there, even though we don't write it. So it becomes a 600. So I have a 600x. When I take 1.6 and I move it 2 places to the right, it becomes a what? 160. X again. And then when I take the 0.08 and I move it twice, I get what? 8. So minus 8. You see it? Okay. And then on the last one, 151.93, 2 places to the right, it becomes 15,000. You don't have to put a comma. Oh, is it 2? Did I write the problem down wrong? Okay. Do you want me to keep it this way or change it? My problem won't answer the book. Okay. So I just wrote it down, everyone, wrong. So just go in here and change that. I'll put it in blue. 2, 2, 2. 2 down here. Oh, 2. All right. So now we have cleared the fractions. Actually, we didn't have fractions. Cleared the decimals, and we don't have grouping symbols. So we go on to step 3, which is to collect like terms. Any questions? Good? All right, so we have 760x, because I put 600 x's together with 160, minus 8 equals 15192. I've just collected like terms, left side. Step 4, I want to get the variable term, 700x by itself, so I will do what? Add an 8. The result of that is a 760x on the left, an equal sign, my 8's canceled, 1,500, no, sorry, 15,200, right? And final step, well, before I check it, but I'm not going to, is to do what? Divide by 760. Yeah, so you might need your calculator here, all right? If you do that, you should get x equals, anyone get it? 20? X is 20.
But you couldn't, I did it the other way. I didn't,
Distribute out first?
no, well, I didn't do it to make them all whole numbers. I left them as
Decimals? Well, then you use your calculator a lot, right? I would want you to get it over to not, yeah, but here's the reason why. In this problem, all your decimals turned out to be nice numbers. But there are things called non-repeating, non-terminating decimals that are like one of them, 0.33 isn't repeating, it's non-terminating. So 0.333 forever is not something you can type into your calculator. At some point, you have to stop putting the threes. So as soon as you do that, you start to create what's called error. Okay, E-R-R-O-R, error. You get error in rounding because you've stopped somewhere. But if we convert over, you know, move all our decimals over, we have nice integers, then we kind of get rid of that. So, and I want to see the skill. I want to see that you know how to do it. All right, let's get on with today's material. Okay, if you have any further questions on your homework, I will address that, you know, on my office hours, or you go to the tutoring lab. We're going to start chapter 5. We're going to do 5.1. I do need to pass around the sign-in sheet, so let me get that going here.
Do you ever work to that?
Do I work a lot?
Do you work to that?
Oh, no. I do not work the lab. Yeah, no. I don't think many of us do. I don't think any of us do, to tell you the truth. Yeah. Oh, yeah, that's right. If some of our part-time instructors also work lab hours, yeah. Okay, so we're going to start chapter 5, section 1, and this is called integer exponents. All right, so before we even begin talking about integer exponents, let's make sure we understand what an integer is and then what an exponent is, because those are two very distinct things. First of all, an integer, anyone know what an integer is? Those are the numbers that you first learned as you were learning math, okay? The numbers were, I'm going to leave a space here intentionally, 0, 1, 2, like counting numbers, 3, 4, 5. I could keep going forever, right? Every one of those numbers is an integer. But you also have the negative numbers, okay? -1, -2, -3. Those are integers. So that list goes to the left forever also. So someone give me an example of a number that is not in this list. 1/4, okay? The fraction 1/4 is not in that list. These are integers are whole numbers, either positive or negative, including 0. All right? That's what an integer is. With me? Okay. So we've got the definition of what an integer is. Now what's the definition of an exponent? Anyone else need to sign in? Okay, it's the power that we put on something. So when we write something, and the best way to talk about an exponent is to give you an example. If I write x and I put a 2 up here, this 2 right there is called the exponent. And then what do we call the thing on the bottom? Anyone know what that's called? It's called the base. Good. So you have the base and then the exponent. So what we're going to talk about today are integer exponents. Right now, in that example I have right there, the green, that 2, is that 2 an integer? The green 2, is 2 an integer? Yes? Is it an exponent? Yes. What we want to talk about today are anytime your exponent is in any integer. So x to the second power means something, but what does x to the -2 mean? Or what does x to the -7 mean? And we're going to have to define all that. So that's where we're headed, all right? So let me now go and talk about some stuff that you should have seen at some point. So anytime it's something you should have seen, I'll put recall. That means recall from previous class or something like that. What the definition of something like x to the first power meant. Well, x to the first power meant just x, didn't it? What did x to the second power mean? X times x, right? X to the third power, x times x times x. X to the fourth power, x times x times x times x. So all the exponent told us, when we look at it this way, is how many of these x's we need to multiply together, right? So if I go down and I write, I could keep going here, but if the last one I put x to the n, then wouldn't that mean x times x times x? And how many of them would I have total? How many x's would be in that list? Well, if it was x to the fourth, I had 4 x's, right? X to the third would be 3 x's. X to the n would be how many x's? The next one would be fifth, right? And I'd have 5 x's. Then 6 would be 6 x's. But if I have x to the n, how many x's would that be? If I did x to the infinity, it would be that. How about this? Wouldn't that just be a total of n x's? Wouldn't that be n x's? So if it was x to the 10th, it would be 10 x's, right? X to the 20th, 20 x's multiplied. X to the n would be n of them. I don't know what n is, but it would be n of them, right? That's the general formula for raising x to a power. If n equals 1, 2, 3, forever. So as long as x is a positive integer, see, these are my integers, but they're positive, then all that the power did was told us how many times to repeat the multiplication. We're interested today in talking about what happens when that integer, when that number up there is negative. Things change. So I want to now move on to another example, or an example of this. Okay, you tell me, what does 2 to the fourth mean? 2 times 2 times 2 times 2, right? Which would turn out to be, what, 16. What's 2 to the third? 2 times 2 times 2, which is 8. What would 2 to the second be? 2 times 2, which is 4. What would 2 to the first be? Just 2? Yes? All right, let's see if you can pick this up. I'm going to change my color on purpose here. What's 2 to the 0 mean then? 1. Now let's see if it makes sense why it's 1. What happened when I went from the fourth power down to the third power? What happened to my answer? It went from 16 to what? It decreased by how much? By half, right? By half. Okay, when I go from the third power down to the second power, it went from 8 to 4, so it was half again. And then when I went from the second power down to the first power, it went from 4 to 2, so half again. So if I go now from the first to the first to the 0 power, you take 2, divide it by 2, and you get 1, don't you? Doesn't that make sense? It follows that pattern. If it follows that pattern, then what would this be? 2 to the negative 1. How did we get from 16 to 8? Divided by 2. How did we get from 8 to 4? Divide by 2, right? How did we get from 4 to 2? Divide by 2. How did we get from 2 to 1? Divide by 2. How do we get from 1 to, well, we divide by 2. What's 1 divided by 2? Yes. What's 1 divided by 2? 1/2. That's it. 1/2. I took the 1 here, and I divided it by 2. So 2 to the negative 1 is actually 1/2. It's not negative 1/2, it's 1/2. What do you think 2 to the negative 2 would be then? You take half of a half, right? Half of a half is a fourth. What do you think 2 to the negative 3 would be? 1/8. We'll do one more. What's 2 to the negative 4? 1/16. You'll see that? It goes the other way, except as fractions. So instead of having 16 on top there, we have 1/16 on the bottom. Instead of 8, we had 1/8. Instead of 4, we had 1/4. Instead of 2, we had 1/2. And in the middle, we've got the 1. That's a pattern that we want to see. Now, there is another pattern that I need you to see also. I'm going to try and point this out here by highlighting it. One, let me see. I'll highlight these after I write them down. All right. Pay attention to what I highlighted here. Do you agree that what's in the yellow is also what's right to the left of it? So 1/4 is 1 over 2 squared. And 1/8 is 1 over 2 cubed, right? Because 2 times 2 times 2 is 8. And then 1/16 is 1 over 2 times 2 times 2 times 2, which is 16. But if you do it that way, then what would, see if you can follow this, what would 2 to the negative 7 be? So I'm going to go back to 2 to the negative 4. What was 2 to the negative 4? It was 1 over 2 to the positive 4. Not multiplication. You're close. Wouldn't this be 1 over 2 to the 7th? Good. So 2 to the negative 4 is 1 over 2 to the positive 4. 2 to the negative 3 is 1 over 2 to the positive 3. 2 to the negative 2 is 1 over 2 to the positive 2. So what's happening is that anytime we have that negative, we have to turn it into a fraction, 1 over, and then it's just take the negative off the exponent. See that 2 to the negative 7 is 1 over 2 to the positive 7. What do you think 2 to the negative 8 would be? 1 over 2 to the positive 8. What would 2 to the negative 9 be? 1 over 2 to the positive 9. What would 2 to the negative n be? 1 over 2 to the positive n. Good. That's what we want to kind of take away from this right there. All right, we're going to be able to do another example here. I'm going to ask you to do it, all right? Let's see if you can do this on your own or with your neighbors. I'm going to make a table, and I want you to write what's on the other side. So I want to know what 3 cubed is, 3 squared, 3 to the first, 3 to the 0, 3 to the negative 1, 3 to the negative 2, 3 to the negative 3. Yeah, that'll be good. So I want you to tell me what these pieces are here. If you have a question, raise your hand. I don't mind coming by and taking a look at what you got. I've filled out the table. See if yours looks anything like mine. And if any of those you don't get, just raise your hand. I'll come by and take a look at what you got. Yeah, so all you have to do now is just do the powers on those. Okay. Anyone have a question on this? No? You see it now? Okay. Right next to this, I want to ask a question here. What is 1 to the 4th power? What's 1 to the 3rd? What's 1 to the 2? What's 1 to the 1? What's 1 to the 0? Oh, sorry. 1 to the 0. What's 1 to the negative 1? What's 1 to the negative 2? What's 1 to the negative 3? So what's 1 to the 4th? 1 times 1 times 1 times 1, right? What's 1 times 1 times 1 times 1? It's 1, right? It's multiplication, right? What's 1 times 1 times 1? 1. What's 1 times 1? 1. What's 1? It's 1. What's 1 to the 0? This one's a little trickier. Look at our answers here. What are we doing as we move from one to the next? It's staying the same, isn't it? Really, we're dividing it by 1 every time. What's 1 divided by 1? It's 1. What's 1 divided by 1? It's 1. What's 1 divided by 1? It's 1. What did we do on the table on the left? We went from 27 to 9, which meant we divided by what? 3. What's 9 divided by 3? 3. What's 3 divided by 3? 1. What's 1 divided by 3? 1/3. What's 1/3 divided by 3? 1/9. And you see, every time you have one of these, what happens is you divide by something. The same thing every time. On this table, the only way to get from 1 to 1 to 1 to 1 to 1, keep going, is just divide by 1. So when we divide by 1 on this next one, we should get 1 again. And then divide that by 1, we get 1. And divide that by 1, we get 1. And divide that by 1, we get 1. It's just 1 all the time. That's the only number that does that. Yeah. So 1 to any power is what? 1. Okay? Remember that. 1 to any power is 1. So I'm going to put that next to this. So 1 raised to n is equal to 1, always. One to any power is 1. All right, what I'd like to do is give us one of our first, I guess, properties now, written down like the way it appears in the book. All right. X to the n, or sorry, x to the negative n is equal to 1 over x to the positive n, which is equal to 1 over x to the n. All right, let me try and explain what this is saying. I'll help explain what it's saying by putting an example, specific example right underneath it. The blue is a specific example of that property that's in red. We said earlier 3 raised to the negative 2, right, meant 1 over 3 squared, 1 over 3 to the positive 2. Didn't we say that a little while ago? Now, why is the 1 over 3 squared equal to 1/3 squared? The 2, right? But when you have a fraction, this is very important. When you have a fraction, like we do here, 1/3, and you raise it to the second power, that second power goes on the top and the bottom. In other words, this turns into 1 squared over 3 squared. The squared goes to both the top and the bottom. But what's 1 squared? We just said 1 to any power is 1. So isn't that really just 1 over 3 squared, which is 1 over 9, right? But this is this, isn't it? Okay, so up there in the red is the property the way it appears in the book. I just don't want it to confuse you. Like, where in the world they get that parenthesis from around the 1 over x? All they're doing is basically this right here. Another way of saying this, okay, another way of saying this property in red is this. If you have something raised to a negative number, right, like that x to the negative n, what you can do is you can rewrite it by dropping it to the denominator and making it a positive power. So if I write, as another example, x to the negative 4, can I just write that as a 1 over x to the what? Positive 4. So having a negative power on the exponent here, to make it not negative, we put 1 over it, and that gives us the positive power. That's an important property of this exponent. Anytime you have a negative exponent, you can basically drop it to the bottom, and it becomes a positive exponent. But you got to remember to put a 1 over it. You can't just change it to x to the 4th. Yes? We're about to. Yeah, we're about to. I'm trying to take you slowly into this. Okay, let's try a couple of examples now, all right? Real like problems that you would find in your book. All right, on these problems, I want us to try and simplify what these mean. So A, what's 4 to the negative 2? What does that mean? Or what is that? What's 4 to the negative 2? 1 over 4 positive 2, but what is 4 to the positive 2? 1/16. So your answer is 1/16. So that's it. That's our answer, 1/16. Done. Next one. What's negative 4 to the negative 3? This one's tricky. Negative 4 to the negative 3. You have something being raised to a negative power, don't you? That negative power is negative 3, right? According to what I just said, if you have something, doesn't matter what it is, x to a negative power, you rewrite it as 1 over whatever that x is to the positive power, don't you? So my x in this problem is actually what? My x is that negative 4 right there, isn't it? That's my x. Okay, so let's see if we can rewrite this using that property. This should equal 1 over x, what's x? Negative 4 to what power now? Positive third. The question remains right now, do I need the negative 4 in parentheses or not? You absolutely have to have it in parentheses. Now, I'll explain why, because I'm going to do another example after this that you'll hopefully see the difference. I need that negative 4 in parentheses. Now, what does negative 4 to the third power mean? It's negative 4 times negative 4 times negative 4, right? Which is, it's 64, but is it positive or negative? It's negative because 3 negatives make a negative, don't they, when you multiply? So you get negative 64. So your answer is 1 over negative 64. That brings me to a very classic problem here. It's important that you see the difference between these two. I'm putting them one on top, one on the bottom. One of those, the answer is 16. One of them, the answer is negative 16. Which is which? Top 116? Bottom one's negative 16? You have it the other way? Let's start with the bottom one. The bottom one, I think, is the one that's easier to see. Whatever's in parentheses, I'm squaring, right? Doesn't that mean negative 4 times negative 4? So the bottom one says, take the negative 4, multiply it times itself, negative 4. Negative times negative is positive. On the top one, however, what we really have is this. Negative 1 times 4 squared. That negative out front is actually negative 1. And because there's not a parentheses around the whole thing, the 2 is only acting on the 4, not the negative. So you must square 4, not negative 4, and then, order of operations, exponents before multiplication. So I square the 4 first, then I come in with the negative 1. So I would go negative 1 still out front, 4 squared is 16, negative 1 times 16 is negative 16. This right here is a problem that I put on the test all the time to make sure that students understand the difference between having the parentheses and not. Because it does. And so on part B, we had parentheses, didn't we? So that means when we brought it down on the bottom, we had to keep it in parentheses and then cube it. All right, let's do another one. Fractions, you love fractions. 2/3 to the negative 2. I have a negative exponent, don't I? What's the x for me here? The whole thing, the whole 2/3, that's my x, right? So according to that formula we had there, it should become 1 over x to what power? I'm sorry, not x. 2/3 to the what? 2. Isn't that what that becomes? What is 2/3 squared mean? Isn't that 2/3 times 2/3? And that, don't you just multiply straight across? And you get 4/9. What is, does anyone remember what 1 over a fraction, what happens when you take 1 and divide it by a fraction? Right here. No? What I'm doing is this, 1 and I'm dividing it by 4/9, right? That's what I'm doing? Does anyone remember that you can convert division into multiplication? But you have to flip, right? Okay, so don't I do 1 and then I'm going to use my old symbol, 1 times 9/4, right? What's 1 times 9/4? 9/4. So what really happens here, when you have 1 divided by 4/9 over here, all that happens is basically the 4 over 9 flips and becomes a 9 over 4. So this becomes 9 over 4 equals 9 over 4, and we're done. It's going to take some practice, everyone, getting used to this. Okay, my last one here. What is negative 9 to the negative 2? Be very careful. The negative 2 is an exponent, isn't it? Is the negative 2 acting on a 9 or a negative 9? Just the 9. Just the 9, because the negative is like a negative 1 out front. So let me rewrite that. This is really a negative 1 times 9 to the negative 2. That's the way you should see that. Because the negative 9 is not in parentheses. Now, what is 9 to the negative 2? 1 over, right? 1 over what? 1 over 9 to the positive 2, right? So what I did there is the 9 to the negative 2 became 1 over 9 to the positive 2. Do y'all see that? What's 9 to the positive 2? Raised? 81, isn't it? 81. So not multiplication, we're doing power here. So times 1 over 81. What's negative 1 times 1 over 81? Negative 1 over 81. So I don't really need the negative 1 written out there anymore. That's it. Okay. Now, let me see. We've got about 15 minutes. I want to do one more property before I give you a couple of problems to do on your own. You're going to have to practice this, all right? Be careful with the parentheses and everything else. Can I move on, or does anyone still need that? Or well, the negative comes out, and you just keep it out there until you've resolved what all that other stuff is, and just bring it in at the end. I don't know if that answers your question. Okay. I don't think that makes a stupid question, though. I've heard stupid questions. They're usually not in math classes, though. They're usually just out there, and when you're out there in the real world, you just hear very stupid questions. Okay, how about this? The next rule, or your first exponent rule, what I gave you before, it was a property of exponents. This is a rule. It's called the product rule. So let me try and get to the rule by showing you an example first. If I say take 3 squared times 3 to the 5th, what do you think that becomes? Okay, it's 3 times 3. That's the first one. That's 3 squared. Times, the other one is 3 times 3 times 3 times 3 times 3. Right, so we had 5 3s there. And 2 3s in the front. Y'all agree with that? How many 3s is that? 7. So isn't that just 3 to the 7th? How else could we have gotten that 7? Look back at the original problem. Where do you think that 7 actually comes from? That, whoa, what did I do? If I take that 2 up there on the 3 and the 5 there, and I add them together, I get 7, don't I? That's not a coincidence. That is the rule. Okay, the rule says that if you have the same bases, here we have the same bases, right? Then if you multiply them, product, the rule is that you just add the exponents together. So I'm going to put the rule in black below this. If I have a base x raised to some power n times x raised to some different power m, the answer is x to the n plus m. I add the two together. Let's do a couple of examples, and then I'll give you some work to try on your own here. What is x to the third times x to the negative 2? Yeah, I did not put a dot between them, okay? I didn't put a dot between them, but it's implied multiplication. So there is actually a dot there that we don't write. If it's not written, you just know it's multiplication. That should just be x to the first power, right? Because it's 3 minus 2. You're adding a negative 2. So this is just x to the 1, which is just x. All right, what would x to the negative 4 times x to the negative 3 be? X to the negative 7. Now, in this math class and a lot of math classes, we don't like to leave our answers with negative exponents. So we switch it over, 1 over x to the positive 7. I'll box my answers here. So the x to the negative 7 wouldn't be wrong, so to speak, but a lot of times we ask you to have all your answers have just positive exponents. Okay, how about this? How about 5 to the negative 2 times 5 to the 4th? 5 to the 2nd. Because you're adding them together, right? Negative 2 plus 4 is 2. And what's 5 to the 2nd? 25. How about this? X to the 3rd, y to the 4th. That's right. The property says, if you go back up and look at it, you must have the same base. Those bases are not the same, are they? So you can't use this rule. Okay, so I'm going to put that here. Rule does not apply. I doubt you're going to see anything like that in your homework, but I don't want you to get all gung-ho and carried away with this and be like trying to make that into something it's not. You have to have the same base before you can add these two together. So you can't turn that into xy to the 7th or something like that. It's not gonna, that just doesn't work. All right. Last one, I think.
So we just leave it like that, right?
Yeah, you won't even get a problem like that. Just be careful. That's all I'm saying. X to the negative 3. I mean, sorry, x. I put a y. Y to the 7th. Y to the negative 2. Y to the, well, I'll just put y. What's that? And it's multiplication between all those. What do you think you do? Yeah, they all have the same base, right? So all you have to do is add up all their exponents. What are the exponents here? Negative 3 plus 7 minus 2 and 1. Good. Don't forget there's a 1 on that y, right? There's a 1 right there. Don't forget that one. So plus 1 at the end there? So what's negative 7 or negative 3 plus 7 minus 2? What is that? Y to the 3rd power. You just add up all these numbers and you should get a 3. So y cubed is the answer. Okay, I think with 5 minutes left, I'm not going to have a whole lot of time to let you work on anything in class. What I'm going to do, though, is if I could get one person to sacrifice one sheet of paper. You got it? Okay. If you could put today's date on the top. So it's the 28th. 28th. Put quiz. Write your name legibly, and then pass it around. So everyone's going to get an attendance quiz grade today just for being here. Everyone gets 100, all right? But make sure you sign that. Make sure I can read your name. Don't make it all like, you know, hieroglyphics. I'm going to put the homework assignment on the board. But before I did, it's kind of off topic, but did anyone hear about, is it Jimmy Buffett, the real rich guy? Did you hear about his challenge that he's put out? Yeah, $1 billion to whoever can fill out the college NCAA men's tournament bracket. I don't know, how many of you follow that a little? March Madness. In March, the top 64 teams in the, well, I think it's more than 64 now, but top teams in the country get into a tournament. They place them into these brackets, 64 teams. That means they play 32 games in the first round. The winners go on. Now they play 16 games. Then they go on 8 games. They go on 4 games. They go on 2 games. They go on championship game. But before the tournament starts, you know the first 32 games. So you can sit there and you can try and pick who's going to win, and then who do you think is going to win the next round. And it's called filling out your bracket. Okay? If you fill out your bracket correctly, if you guess it before a tournament, you turn it in, and that's what happens. Every single game you get right, Jimmy Buffett has said he'll give you $1 billion. You have to get every game right. So your whole bracket has to match exactly what happens. $1 billion. To give you an idea of how difficult that is, I want to show you something. If I have, let's just say I had 4 teams, okay, and they were going to play. What I would do is I would guess who's going to win each game, right? So let's say I have team A, B, C, and D. Then when I pick that first game, who's going to win, I could pick A or I could pick B, right? And then here I could pick C or I could pick D. So how many different ways could that happen? I could do A on top, C on the bottom, A on top, D on the bottom. I could do B on top, C on the bottom, B on top, D on the bottom, right? So how many different ways could I have actually done it? 4 ways, right? Well, how many games were there? No, right here. How many games were played? 2. 2 games, right? If I take 2 and I raise it to how many games there were, so for each one of these I can pick 2, right? 2 here and 2 there. So if I take 2 and raise it to the second, I get 4, right? That's how many different ways we had that we could have done it, right? That's what happens if you only have 2 games. The first round in the tournament is 32 games. So that's 2 to the 32 different ways that you can just fill out the first round. Then the second round, there's 16 games. So that's 2 to the 16 ways. The next round, there's 8 games, 2 to the 8. The next round, there's 4 games, 2 to the 4. Next round, there's 2. 2 to the 1, and that's it. Now, we just learned this rule, right? Same bases. Same bases? Add up the exponents. What's 32 plus 16 plus 8 plus 4 plus 2 plus 1? I believe it's 63. Let me see. 40. Is it 63? Okay. 2 to the 63. If you take your calculator out and you type in 2 to the 63 on your calculator, the number is astronomically large. Okay? I don't even know. I think it's something with like 18 or so zeros. Who has a calculator? That's how many possibilities. If anyone has a calculator real quick. Oh, I have one on my phone. I got it. Oh, wow. I have 6 messages. What the hell? 2 raised to 63. Okay, yes. So it's a 9 with 18 zeros after it. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, that's how many different ways you could do it. So you start, I pull out my first bracket and I fill it out. And I put it to the side. That's how many different brackets can be filled out. Different, distinct brackets. Look at, these are numbers that you can't even get your head around. This is the millions, billions, trillions, gazillions. Okay, right? We start getting into like really big numbers. And I believe, how many people are on the planet? Is it like 9 billion? That seems like a lot. 9 billion. Let's go with 10 billion. I don't care. Let's go with 100 billion. It doesn't matter. Here's millions. Here's billions, right? Let's just say we had 100 billion people on the planet. If you divide 100 billion into this number, all you do is you take out these zeros. So just look at this number right here. What's that, 9 million? Okay, if all 100 billion people on the planet, and that's huge, if 100 billion people filled out 9 million different brackets, we would be guaranteed a winner if that happened. If, you know, you filled out 9 million brackets, different than your 9 million, different than your, and 1 billion people did that. That's why Jimmy Buffett's fine. He's going to be just fine. He's given nobody $1 billion. Now, could it happen? It could, right? It's like the lottery. It could happen. It would be, there's a little more involved in it, right? Because when Duke plays UTSA, you can pretty much say who's going to win, but that's why they call them bracket busters, the people who mess it up. Nobody has ever got, I believe out of all the brackets that have ever been made, I believe nobody, the closest anyone's come is getting the first 32 right. The first games, that's it. After that, nobody has ever gotten the second round completely right, after the first round's been right. Okay, your homework, will you give me 1 minute? I'm sorry I've kept you over, but that kind of relates to what we did, right? A little bit. Okay, our homework is page 345. I want you to do 1 through 25 odd, and do 2 through 26 even if time permits. In other words, do all the odds so you can check your answers. Do all the odds between 1 and 25, check your answer in the back of the book. Then to reinforce what you've learned, go and do all the evens, 2 to 26. And then come in on what? Thursday with any questions, okay? And what we'll do is we'll pick up, we have to finish this section off next class. Y'all have a good day. Yes. Well, you know what? I do have to say that. Anybody need to sign in? Make sure you get that quiz. Where's that quiz sign in? Everyone got that? Right here.